Hello and welcome. It is January 3rd, 2026. We are now standing inside the 48-hour window. In less than 2 days, the interstellar object known as 3I Atlas will make its closest approach to Earth. For months, we have been tracking this visitor from the depths of deep space, watching it trace a hyperbolic trajectory that will eventually sling it back out into the interstellar void, never to return. But as it rushes toward us, it is not behaving like the inert rock or the simple comet we expected. It is speaking to us in the language of physics and light, and the message it is sending is becoming increasingly difficult to translate using our standard dictionary of planetary science. Tonight, we are looking at a breaking development that changes the entire conversation. A newly published study released just hours ago has analyzed the behavior of the object's anti-tail, that sunward-pointing jet of material that has puzzled astronomers since it first appeared. We have known about the jet for months. But what we didn't know until we stripped away the noise and looked at the raw motion data from July and August of this year was exactly how that jet was moving. When we observe comets, we expect chaos, we expect tumbling, we expect jets to erupt from random active regions on the surface as they rotate in and out of sunlight. A comet is usually a dirty snowball tumbling through the dark. When sunlight hits a pocket of ice, it sublimates, blasting gas and dust into space like a chaotic thruster. That is the baseline. That is what nature usually does. But 3I Atlas is doing something else. The new analysis reveals a distinct periodic wobble in the jet. This isn't the random sputtering of a melting surface. It is a rhythmic, predictable oscillation. By tracing this wobble back to the nucleus of the object, researchers have pinpointed the source of the emission. The data indicate that the jet source lies within just 8 degrees of the object's rotation pole. This matters because of geometry. If the jet is coming from the pole and the jet is pointing directly at the sun, then the rotation axis of the object itself must be pointing at the sun. Imagine a spinning top. Usually, if you throw a rock into space, it tumbles end over end. But 3I Atlas is spinning like a top that is lying on its side with its pivot point aiming directly at the star it is orbiting. This geometry is extraordinarily unlikely. In the chaotic billiard game of interstellar space, objects don't just naturally settle into such a perfect alignment. The probability of a random object having its rotation axis aligned with the sun by chance is estimated at just 0.5%. This contradicts what we previously thought. We assumed the anti-tail was a transient feature, perhaps a trick of perspective. But a pole-aligned jet implies stability. It suggests that as 3I Atlas falls through our solar system, it is keeping one face locked in a specific orientation relative to the solar vector, not through tidal locking, but through this precise rotational alignment. This alignment has consequences for everything we are observing. It affects how we calculate the object's size and how we interpret its brightness. Most importantly, it affects the jet. The jet is the fingerprint of the object's internal engine. If the engine is located at the pole and the pole is pointed at the sun, then that engine is running at maximum efficiency. It is getting constant sunlight. There is no day and night cycle for that specific patch of ice. It is in a state of perpetual noon. This explains why the jet is so consistent. It is a continuous stream. However, the story doesn't end there because 3I Atlas didn't just fall in. It swung around the sun and passed perihelion on October 29, 2025. When an object passes perihelion, the geometry of the orbit flips. If you point your finger at a light bulb and walk in a circle around it, eventually your finger isn't pointing at the bulb anymore. The stable day side should have ended. The pole that was pointing at the sun should have started pointing away. The jet fueled by sunlight hitting that pole should have shut down. That is what the standard model predicts. But that is not what happened. New images from the Hubble Space Telescope and ground-based observatories show that 3I Atlas continues to emit a sharply columnated sunward jet, despite now moving away from the sun. This contradicts what we previously thought. To explain this, astronomers are forced to assume the existence of a second major ice pocket located near the opposite rotational pole. This second pocket had to wait until exactly as the object swung around the sun to trigger. It's a perfect handoff. Pole A drives the jet on the way in, pole B drives it on the way out. When you combine those probabilities, the 0.5% chance for the first alignment and the requirement for a second perfectly placed polar pocket, the numbers crash. The odds drop to an astonishing 0.02%, or 1 in 40,000. We have gone from unlikely to statistically absurd. We are looking at an object that seems engineered to maintain a sunward pointing jet throughout its entire passage. Why would a rock need to do that? While the natural explanation requires more and more coincidences, the artificial explanation, the idea of a defunct probe or a stabilized craft, starts to look simpler to some theorists. Then there is the shape of the jet. Observations from December 15th show something that physically shouldn't exist. The anti-tail is remaining tightly columnated over distances exceeding 500,000 kilometers. That is further than the distance from the Earth to the Moon. A normal comet tail fans out as gas expands into a vacuum and is pushed by the solar wind. But 3I Atlas is shooting a laser-straight beam of matter. To keep a stream this tight, you need either phenomenal ejection speed, very heavy particles, or magnetic confinement. None of those things belong on a standard dirty snowball. The final clue lies in the rotation period. The observed jet wobble suggests a rotation period of approximately 15.5 hours. At 15.5 hours, a 2-kilometer object is spinning too slowly for centrifugal forces to matter. It isn't tearing itself apart. The activity is purely thermal or internal. As 3I Atlas races toward its close encounter in less than 48 hours, astronomers are looking for the slightest deviation in its orbit that would indicate non-gravitational acceleration. We are looking for the spectral signature of refined metals. We are looking for a hello. Whatever its true nature, 3I Atlas is already reshaping expectations. It has taught us that the universe is capable of producing geometries we thought were impossible. It has shown us that our models of cometary physics are, at best, incomplete. We are witnessing the moment where we move from assuming everything is a simple rock to realizing the galaxy is full of complex, dynamic systems. 3I Atlas is leaving, but it has woken us up. It has reminded us that the sky is not a wallpaper. It is a frontier.